Hello, everybody, and welcome back to the Nutritional Revolution podcast. Today, we have for you guys Dr. Stephen O'Brien, and he is an internationally recognized neuromuscular physiologist whose research explores how sex-specific aging and age-related disease, acute exercise, fatigue, and long-term training adaptations influence the integration between the brain, spinal cord, and skeletal muscle. His work aims to develop innovative, evidence-based strategies to enhance physical function and performance across the lifespan. Dr. O'Brien is an expert in a range of advanced neurophysiological techniques, including electrical and magnetic nerve stimulation, transcranial magnetic stimulation, also known as TMS, and electromyography or EMG, and assessments of skeletal muscle force and power. His research bridges mechanistic physiology with real-world applications in clinical, athletic, and aging populations. The study that we dove into, I think, is so great. We really focus solely on women aged 18 to 80 and how muscle contractions change over time and force. And it's just, amazing. You guys will love it. Enjoy the episode. Hello, everybody, and welcome back to the Nutritional Revolution podcast. We have for you guys Dr. Stephen O'Brien logging on all the way from Australia. Thank you so much for joining us.
Morning or good afternoon to you, I guess.
Yes. Yeah. Good morning for you. Yeah. It's actually, what time is it for me? Oh, it's 12:30. So, it is right around noon. I'm super excited to talk to you about your article here. So we're going to be diving into the contribution of age and sex hormones to female neuromuscular function across the adult lifespan. I'm very excited to hear all about this. But before we start, I'm going to have you break down your two truths and a lie for me.
Yes, so there was a few different ways that I thought I could go with this. But I thought obviously being from Australia and Australia, I guess, being famous for its wildlife, I thought I'd give a couple of examples of experiences I've had with some wildlife here in Australia. So the first one is that I've been bitten by a eastern brown snake, which is the second most poisonous snake in the world.
Ooh. Okay.
That's the first one. The second one is that I've had a kookaburra come down and swoop food literally out of my mouth as I was taking a bite. That's the second one. And the third one was that I have seen a great white shark fully breach out of the water right near me where I was in the water actually surfing. So
okay.
They're the three. So I've got bitten by a brown snake, kookaburra stole my food out of my mouth, and a great white shark breached out of the water right near me.
Wow. Do you know what the most poisonous snake is?
Yeah, it's a viper, isn't it? Isn't it? I don't know if it's in the US or maybe Africa. I don't think it's in Australia, but we've got lots of poisonous animals here.
Yes, I'm heard. Like the most. They put them all. They're all there. Yeah.
Knock them all down here for us.
Yeah. That's wild. We have a lot of rattlesnakes here. I'm not sure how those compare on the poisonous. I mean, they're obviously poisonous, but I don't know how many people are dying from them. I think it just destroys a lot of tissue. I think you can die, certainly, but yeah. Okay. Well, that sounds gnarly if you got bit by a eastern brown snake. I feel like the kookaburra story sounds really real. And the great white shark one that sounds scary, but also very real. I'm going to go with the brown snake bite as a lie for your sake. I hope that was a lie. But don't tell me the answer, and we'll get to hear the answer at the end of the episode. This will be a fun two truths and a lie to learn about. What got you excited about diving into neuromuscular deterioration with age and this study we're going to dive into today?
So I started off just in generally neuromuscular physiology in my PhD, and that was mainly during exercise. So I was really interested in understanding how the brain, the spinal cord, and the muscle, how they all communicate and interact, and how mechanisms within those different regions might basically lead to somebody stopping exercise or reaching their, let's say, limit. I did look at that more from a point of view as maximal power, so more sort of short duration, maximal effort type exercise.
Mm-hmm.
And I was sort of led down that direction for some research done by a lady here in Australia known as Janet Taylor, who was investigating a lot of the mechanisms of fatigue from a neuromuscular perspective. And just the techniques that are used in that type of work I found really interesting. So there's a lot of stimulating the brain and stimulating the spinal cord at different levels and trying to sort of decipher the output that goes to the muscle from those stimulations. So I found all that stuff really interesting and something that I wanted to try and learn how to do myself. And so that was sort of framed my whole PhD. Post PhD, I was looking sort of for the next thing to move into, and I always had an interest in sort of general neuromuscular aging, and so I did a little bit of work earlier on different types of exercise we can do to try and promote increases in muscle strength and mass and bone strength and stuff like that as in older adults. And then the female specific aging stuff sort of came about from a colleague of mine, Danielle Hyam. So Danielle did her PhD at my same university, me at similar time. We did some teaching and some stuff together as well. And she moved to Deakin University here in Melbourne on a postdoctoral fellowship with Professor Séverine Lamont. And Severine Lamont is a molecular physiologist and doing a lot of work and really leading the way, I guess, in the
Whoa.
molecular, I guess, sex differences and how that influences skeletal muscle.
Cool.
Yeah, so they had a project they were about to embark on, and Danielle reached out to me in terms of doing some form of functional sort of neuromuscular stuff, and that's how that sort of ball got rolling. Yeah, I've kind of that was around 2021, so a few years ago now. And yeah, that's leading to the direction, I guess, that I'm in at the moment.
Yeah, fascinating. Well, definitely appreciate you doing research in women. I have to say that.
Yeah.
We need it. And for our listeners, what can you kind of give us a definition of like what is neuromuscular deterioration? What is
Yeah. So we're basically, if we look at the whole motor pathway, so if somebody wants to generate some force or and do any type of movement, essentially the muscle needs to receive a signal from the brain and the spinal cord for it to be able to contract and go through the process of generating some form of force or tension to enable movement. So that's force or movement, movement in terms of force exerted on the environment, also forces exerted on the skeleton. But neuromuscular function, let's say, sort of encapsulates that entire motor pathway. So we don't just look at one particular area or region, we try and look at things more holistically and try and understand things from what's happening in a whole body sort of perspective rather than sort of at a single molecular or little level.
Okay, cool. Well, I'm very excited. So again, all women, and you looked at ages 18 all the way to 80, correct?
We did, yeah, yeah. So we
Amazing.
sort of kind of cast a wide net, I guess, and try and get the full spectrum of a typical lifespan.
Amazing. I think this is really fantastic. So for our listeners, the literature article, and we'll link into the show notes for everyone, but it is called The Contribution of Age and Sex Hormones to Female Neuromuscular Function Across the Adult Lifespan. So do you want to walk us through a little bit about who you looked at? I mean, we kind of disclosed the age range, but and what you were looking at and how long it took you to do this and yeah.
Yeah. So it was yeah. So where do I start? It was a long process. So there was I mean I'm not a full-time sort of doing this project, but it took roughly I'd say roughly 2 years to collect all the data. As I said, we try to capture a wide range, so 18 to 80 years. We try to get somewhat of an equal distribution across, which we ended up getting at the end, which was pretty cool. Some of the more elderly participants were a little bit more difficult to recruit, but everyone was able to complete the study, which was fantastic. But yeah, we sort of wanted to get a sample which was well representative of the general population. So we didn't want to be too, I guess, narrow in the type of person that we were recruited. So we had a couple of exclusion criteria. So people with cardiovascular or musculoskeletal neuromuscular diseases, things like this, were excluded. And people who generally had a BMI above 35, so it was sort of in the severely obese sort of category, were excluded. just based on some of the difficulty with doing some of the techniques. But we purposefully did that, as I said, to try and get a good spread of the general population. And then obviously there's lots of different co-founders which might come about because of that broad net, let's say. But the way that we sort of ran the analysis, we accounted for a lot of those things. So so we feel we had a really good representation of what a general population would be. And roughly at the end, I think we had 88 or 90 participants go through. So yeah, we had a lot of people. So we got a really good insight into what's happening.
Yeah. So with this population that you're looking at and the participants, you're looking at to just get because this is 18 to 80 is I mean, that's a long time if we were following an 18-year-old to their 80th birthday, right? So we're looking at different people in different age ranges and comparing their neuromuscular function to a different person in a younger age group or vice versa.
If we compare, let's say, the oldest participants to our youngest participants, the key things sort of we start with, if we look at a holistic sort of measure of what neuromuscular function might be, what we basically refer to is their maximal strength and power. So how strong they are and how quickly they can generate force. They seem to be the sort of let's say, the overall functional kind of measures. And then what we want to try and do then is we want to try and decipher, well, why is that happening? So why are older individuals weaker or less powerful? So if we look at some of the literature, so generally, if we take older participants and younger, if we just do that rough classification, adults are anywhere from sort of 20 to 40% sort of weaker. And if we look at power, it can even be greater. So it could be up to 50% lower amount of power that they can generate. So then if we try and tease out what's happening, we can see that as we get older too, we obviously lose a lot of muscle mass and we get sort of atrophy of muscle fibers. So they get smaller and we eventually lose them. And there's a theory that might actually preferentially occur in the type 2 type of muscle fiber, which is considered to be the power one. So generate more force and generate force quicker compared to, say, what a type 1 fiber might be, which generates less force, but is more sort of fatigue resistant, let's say. And
is that like a slow twitch?
Yeah, slow twitch type 1. Yeah. And so some of these mass changes can explain some of the decreases in strength that we see, but they can't explain the whole decrease in some instances. So when we talk about neuromuscular function, we're then trying to go deeper and try and understand, well, then what are the other factors? So aside from mass, there seems to be mechanisms which we refer to as muscular or peripheral. So these are things which happen within the muscle fiber themselves. So for instance, we can refer to what's called the contractility. These are processes happening within the actual muscle cell. And one of the major ones seems to be mechanisms involved in maintaining calcium or calcium homeostasis within a muscle. So that's important for a muscle to be able to generate tension. And the other thing seems to be important in aging too is the neuromuscular junction. So that's sort of the final synapse that happens between the nerve and the muscle cell and helps in the muscle contracting in the first place. And we know that as we get older, we see some of those degenerative effects happening within there as well. But the other side of it is the sort of the central or the neural component. So really what we're trying to do there is we're trying to decipher the signal being sent from the nervous system. So that might refer to the total output from the nervous system or the amount of signal. But it can also relate to the behavior of the signal. So the shape of the signal, the frequency of the signal and stuff like that. And that can all lead to changes in the functional capacity of the muscle. So when we talk about, we're investigating neuromuscular function, what we're trying to do is trying to look at that whole spectrum from the output from the nervous system, the function of the actual muscle cell itself, muscle mass, and we put that in a big bowl and we work out, well, how much is that contributing to the decrease in strength that we see. And if we categorize people, and it's generally what's done is categorizing sort of younger, middle-aged and older adults and trying to look at what's happening. And that gives us some insight, but the idea of something that we wanted to do with this study is by having a large number of participants and having them evenly spread throughout each decade, that enabled us to sort of treat age more of as a continuum rather than classifying it based off, say, 20 to 29 or 30 to 39, etc. And by doing that, what that enabled us to do is to get a bit of a clearer idea of, say, if there's any critical time periods throughout the lifespan where we see that these things start to occur, or we start seeing these
Yeah.
degenerative effects start to happen, and we see if the magnitude of the decline is accelerated at any particular time within the lifespan. So I guess that's the getting roundabout way back to your question, but that process of having so many people and having them spread out over the whole lifespan, that enabled us to model that trajectory
Hmm.
of the decline that we see with age and identify some critical time periods of where people might be, or women specifically, obviously, might be more vulnerable to any decline.
Yeah. I just listening to you explain all this, like how you're monitoring and tracking stuff, I just like technology and what we can do is so incredible. Like measuring the nervous system response or signaling being sent. Like, how do you do that? How do you measure
Yeah, so
that?
so that sort of led to some of the techniques, and some are quite complicated. And
Mm.
to be fair, I think, technology and the difficulty in doing this probably explains why less is known generally about the neural side of things compared to the
Yeah.
muscular side of things. But in our study, we use some stimulation. So
Mm.
we basically, what we do is we get someone to try and generate as much force as they can. So,
Mm.
and we sort of yell at them in a nice way and encourage them to produce as much force as they can to try and get them highly motivated.
Yeah.
And while they're doing that, we can sort of track their force. So we get a continuous sort of measure of their force. And what happens is people will generate their force, but then they'll get to a point where it starts to flatline. So they kind of reach their ceiling.
Hmm.
So with the stimulation, and it can be a little bit uncomfortable, but it's generally well tolerated. Some of the participants might say otherwise, but they all got through it okay. But what we do is when they get to reach their plateau in their force, we stimulate the nerve, so the nerve which controls that muscle, and we see if we see any change in the force. So if someone theoretically reaches their maximal, what we say, voluntary force, if we give them an electrical stimulus and their force goes up, that's indicative that the nervous system is capable of getting more force out of the muscle. It's just not doing it. So there's a decreased capacity of the nervous system to fully, let's say, activate the muscle to its full potential.
Whoa.
So in that way, that can give us a bit of an idea that there's something going on within the nervous system. It can't tell us where that thing
Hmm.
might be happening, whether it's the brain or the spinal cord, but it can certainly tell us more about the capacity of the nervous system to activate the muscle and generate its maximal force. So
Wow.
that's sort of one technique we can use. And the other technique that we use to get a bit of an insight into the nervous system is through electromyography.
Mm.
So there are different forms of electromyography. There's more advanced forms which give you a really clear insight into that, being able to decode that neural signal. That can include what's called intramuscular EMG, where we stick a needle into the muscle and you sort of can measure the signal actually being sent. A sort of, let's say, recent non-invasive measure is called high density electromyography, where basically you can apply an algorithm to the signal and you can sort of tease out more about information about the signal. And at a more sort of a level below that, which is the level that we used in this, and is generally more applicable when it comes to dynamic movements and sport and stuff like that. But it's called bipolar electromyography. And what that does is that just gives us a gross level of indication about how well we're activating the muscles. So let's say
Mm.
what we call the neural drive. But we can put that on individual muscle groups. So obviously, if you're trying to generate as much force as you can with your quadriceps muscle, it's made up of 4 muscle groups. So if we can put these sensors on the different muscles which make up that muscle group, and when we can see if there's any intermuscular differences or anything that's going on which might be different between that whole sort of group.
Yeah. Cool. So you mentioned quadriceps. So one of the movements was a leg extension.
Yeah, so in terms of when we quantified strength in this study, we did maximal isometric force. So isometric meaning there's no change in the length essentially of the muscle when it's contracting, so it's sort of against a fixed resistance. And in that way, we can measure what the maximal strength is.
Mm.
Um, and there is when we go through dynamic movements, we go through movements where the muscle is undergoing changes in length. So the actual force generated by the muscle is not its true maximum because the movement is determined by both the force and the velocity of the contraction. So it becomes a little bit more complicated when you start doing dynamic movements. But we wanted to get some indication of maximal strength during a dynamic movement. So we also did, the leg press,
Okay.
estimated 1 RM from a sort of 5 repetition max test, which is a little
Wow.
bit safer to do in sort of elderly populations.
Yeah, that's I can picture I can't like an 80-year-old on a leg press machine. That's pretty rad. Do you recall what kind of weights they were? I mean, that's probably part of what you were monitoring in the study, but what were some of the 80-year-olds putting up on the leg press?
Um, well, in terms of the leg press, so in this study, I was co-first author with another academic, which is Annabelle, and
Mhm.
Annabelle Critchlow, who was doing this as part of her PhD. She did a lot of the leg press
Okay.
assessments, so I can't tell you exactly what they were pressing out, but yeah, I'm sure it's listed somewhere in the paper.
That's great. I love that. Okay, so you talked about in the beginning, you kind of hinted at determining where within that 18 to 80-year-old lifespan range we start to see some of these changes more significantly occur. Can you share with us well, if there was anything else I'm missing on what you were testing and looking at, and then kind of dive into where you started to see that major shift and your
Yeah,
thoughts
for
around it?
sure. So one key thing that we wanted to sort of look at here was not only identify the trajectory, but was to try and relate any of the changes that we see across the lifespan with the hormonal levels.
Hmm.
So seemed to be one sort of gap in the literature is that identifying these critical time windows,
Yeah.
but also trying to relate any changes to sex hormone levels. Because I mean, it's a difficult thing to do in females, which is probably a reason why they are somewhat underrepresented in this area, as you mentioned at the start. Especially premenopausal and perimenopausal females, where hormones are fluctuating daily. It's hard to be able to do everything on the same day, basically.
Hmm.
But we wanted to try and do a good job at trying to evaluate the sex hormone effect on
Hmm.
these outcomes. That was kind of the main sort of goals of what we were doing. We did the trajectory and we tried to identify where it was happening. Few of the outcomes we seemed to, and the strength outcomes.
Hmm.
So whether that be sort of the isometric strength, but also the 1 RM.
Hmm.
And some of those measures of the contractility sort of within the muscle itself. We identified a period of around 43 to 48 years where we started to see that decline start to be accelerated. So that seemed to be a critical sort of time window of where we saw these things happening. And it just so happens, obviously, that that coincides with the typical sort of age of menopause onset, which
Yeah.
can happen as early as 40 for some women and as late as sort of 55, but that seemed to be happening sort of right bang in the middle of that window. And then when we did sort of do some of the analysis to look at the hormonal effect, those the isometric strength at least seemed to be related to some of the decreases that we saw in estrogen and progesterone postmenopause.
Oh, okay. So you were measuring sex hormones through the lifespan too for
Yeah,
those, right?
we
Yeah.
were. Yep. So everybody had both blood and urine samples to try and quantify the hormonal levels. So we looked at estradiol and progesterone. We also looked at what's called the free estradiol
Mm.
index, which is basically the bioactive, let's say, form of estradiol, and also looked at testosterone as well and the
Awesome.
testosterone index.
Yeah.
So they all had measures of, yeah, as I said, blood and urine samples, and we tried to look at the association with some of the outcomes that we were measuring.
Cool. So, you said, was it age 43 to 48 was the?
Yeah, it was around that range. So depending on the measure, it may have been a little bit sort of, I think the evoked twitches, so those that sort of represented the contractility of the muscle,
Hmm.
they seem to happen a bit earlier, sort of around that 43 to 44. And then the strength measures, so the MVC and the estimated 1 RM generally was sort of 45 to 47, 48.
Wow, fascinating. And were you through this process like were we taking any information on what their training routine is, their protein in their diets?
Mm. Yeah, so obviously, as I said, some of these lifestyle factors can change that age-related trajectory that we
Mm.
see. So that was why it was very important for us that we when we had analysed and identified these critical age periods, we accounted for their physical activity status,
Mm-hmm.
and also their daily protein intake.
Yeah.
And the participants we had, and this tends to be a thing with sort of exercise studies, is you generally do end up recruiting those who are generally fit and healthy. So those who are exercising a lot and generally eating well.
Mm-hmm.
And our participants were either they were meeting or exceeding the sort of physical exercise recommendations of 150 to 300 minutes a week of moderate to
Mm-hmm.
vigorous exercise. Um, so yeah, so we had to account for that, and which we did in our analysis. So even though we had some women that were in their sort of mid 60s who were pushing out forces that were as great as the 20-year-olds that we had. So there was
Oh, I love
definitely that
that.
we could see. Yeah,
Yeah.
it was great. Um, but we did account for the sort of physical activity and some of those
Yeah.
dietary sort of lifestyle factors.
Fascinating. And then I have to ask too, were any of them on oral contraceptive or HRT?
Yeah, so that was another thing that we try to account for as well. So the premenopausal females, we did a sort of separate analysis to look at any potential effect of the menstrual cycle,
Mm.
and also use of oral contraceptives. And in the postmenopausal, any of those who are on HRT, we sort of accounted for those. In our analysis, we didn't see that it changed the sensitivity of the results or the data that we had. It doesn't say that, if we were to look at that just particularly and investigate that research question, for instance, the effect of HRT or menstrual
Right.
cycle phase, that there wouldn't be a change sort of within a participant over different phases. But in terms of its effect on our data, we were able to eliminate those effects. So, yeah, so the results weren't sort of compounded by any of those things.
Okay. Wow. That's interesting too. So, and just to confirm too, so where you saw that drop in the, I might mess up the language, the muscle contractility or the neuromuscular
Yeah.
function, 43 to 48, that coincided with the changes in sex hormones or estrogen and.
Yeah, so with the hormone analysis, we had to focus that just on the postmenopausal females.
Mm-hmm.
So the reason for that is because when we did the experiments, we weren't always able to get the hormone analyses on exactly the same day of which we tested the neuromuscular
Right.
function. So we focused that analysis on the postmenopausal females
Mm-hmm.
just because we knew that if there was differences in days of which we did the analysis, that those fluctuations in the hormones wouldn't have as great a day-to-day, let's say, variability. But that analysis was done just on the postmenopausal females. So we couldn't say that exactly during that menopausal transition that the hormone fluctuation then was contributing to that accelerated decline.
Mm.
But we know that post-menopause that those hormonal fluctuations were related to the decrease in the strength, and also the contractility.
Wow.
The estrogen one or estradiol one is a little bit less clear in terms of its
Mhm.
effect on the strength and the contractility. In that we did show some evidence to suggest that the high estradiol may have improved the contractility, so sort of the quality of the muscle.
Mhm.
But there's also evidence, and we always also showed that increased estradiol might also increase or be related to fat infiltration within the muscle. So that might seem like somewhat a contradictory effect, but fat cells are able to release estrogen. So maybe whether or not it's sort of cause and effect is sort of hard to say, but we need to sort of do a little bit more to understand the estradiol effect on muscle. In terms of progesterone, Professor Lamont's group and some of the stuff we actually just recently published in Journal Physiology as well, but seem to suggest that progesterone might be more related to muscle mass. So the estrogen and progesterone might influence strength in sort of different processes or from different mechanisms.
Whoa. This is so fascinating. So progesterone may be more correlated with muscle size, you're saying muscle.
Yeah.
Okay.
Yep. So with muscle mass and muscle hypertrophy, or
Yeah.
conversely with muscle atrophy, progesterone might be sort of more related to that, whereas estradiol and free estradiol index might be more related to sort of the processes or the contractility of a muscle.
Fascinating.
But as I said, also potentially related to an increase in the amount of fat infiltrated into the muscle. So
Hmm.
a global sort of effect on, the strength of the force. So we need to do a bit more.
Yeah. Man, female hormones are, there's a lot going on there.
There
Uh,
is, there is.
yeah.
Yep.
Wow. I mean, because it makes, so correct me if I'm wrong here. So you're saying in the age ranges where there was more estrogen moving through the body, it was associated with better ability to contract the muscle tissue?
Yeah, so
Okay.
postmenopause. So in
Mhm.
postmenopausal females, those who had higher levels of estrogen and free estradiol index
Oh,
tended to be
okay.
able to generate more strength.
Huh.
And the same with those who had high levels of progesterone, that was also related to an increase in strength. So when we did the correlation analysis, we sort of looked at what are sort of the key predictors of strength. And then
Hmm.
we looked at their relationship, so how well were they correlated? And we found, yeah, that relationship between the estradiol and the progesterone and the isometric strength.
Whoa.
Interestingly, though, we didn't see that it was related to the estimated 1 RM. So there's more. Again, you're probably going to get annoyed at me saying that there's more needs to be done, and I feel like researchers say it all the time, and it's
Yeah.
a frustrating part. But the type of the contraction might influence the relationship between the hormones. So
Mm.
when a muscle is contracting, undergoing changes in length, it just becomes a little bit more complicated. There's more things at play in terms
Hmm.
of the overall outcomes, let's say.
Mhm.
But it is something that we're looking at, and hopefully trying to publish somewhat earlier next year. So
Yeah.
it is, there are things that we're on the ball for.
Yeah. I mean, this is all fascinating, even if you like solely looked at a menstruating female within her menstrual cycle phase. I'd be interested to see like what I don't know if you
Yeah.
did look at that.
Yeah, well, we didn't look at it in this study. I actually have, I'm supervising a PhD student at the moment,
Mm.
Brooke Elba,
Hmm.
and she's a powerlifting coach. So we're
Cool.
actually looking at strength trained or power trained females,
Hmm.
and looking at how the menstrual cycle and the fluctuations in the hormones might influence their performance. And the evidence in the effect of the menstrual cycle phase seems to be seems to be a lot to have been done. Some show
Hmm.
some effects, some don't see effects when it comes to say strength or endurance as well, whereas others do. So if those that do see differences and effects of the menstrual cycle phase tend to not show really big or significant, or they might be significant but not large effects, if that makes
Hmm.
sense. So in elite sport, it might have an effect on sort of overall results, but yeah, the magnitude doesn't seem to be too huge. But it's not super clear on how that influences the sort of the neuromuscular function. There are some groups doing some things where different periods of the menstrual cycle may be related to changes in the firing frequency of the motor neurons, so sending the signal to the muscle, and also the gain of the motor neurons. So basically, their likelihood that they send signals from an input
Hmm.
and their ability to sort of sustain that signal might be influenced by different phases of the cycle. But there's certainly more coming out in terms
Hmm.
of menstrual cycle effects, but it's not something we sort of looked at specifically here.
Yeah. Wow. Yeah, there is a lot to dive into and I mean, I'm sure all our female listeners know it's like everybody's so individual and how their cycle and hormones, I'm sure. I mean, to some
Yeah.
right? There's
And when it comes to elite athletes too, it's seems to be even more variable than
yeah.
sort of females who aren't as physically active. So yeah, it's just makes it more and more difficult. And again, it's not an excuse for not including females more in this type of research, but it's certainly more difficult to try and nail it down. But there's heaps more being done at the moment, which I feel like, yeah, it's obviously a really positive thing. And
Yeah.
um, yeah, there was a conference just recently, I think, in the US on sex differences in women's health,
Oh,
and
yeah. You're
yeah.
talking about the the female athlete conference in Boston?
No, I think this was the American Physiological Society one. I think it was in New
Oh, okay.
Orleans,
Cool.
and I think that was in either October. I think it was in
Okay.
October. I was trying to get there, but it was
Yeah.
a bit difficult.
Yeah.
But yeah, but there's certainly a lot more being done in the female physiology space,
Definitely.
which is great.
Yeah, very neat. So for our listeners who are hearing this and they're maybe in their late 30s and wanting to mitigate this potential decline, do you have any suggestions, whether it's physical training, protein intake, movement, HRT? Like, from what your findings share, that you feel comfortable sharing or
Yeah,
theories?
yeah, for sure. So I think if we look at, and one key thing is, even if we look at physical activity participation across the lifespan, middle-aged and older adults are more likely to engage in aerobic-based exercise. So whether that be submaximal or more endurance-based, like I was saying before, that a lot of your listeners are endurance-trained athletes, which is certainly beneficial. So that's obviously really good for cardiovascular health, VO2, so the ability of the muscle to deliver and utilize oxygen, and VO2 is a really strong mortality risk factor. So that's really important for sustaining. A lot of those aerobic-based exercises are also osteogenic, so especially in females who experience accelerated declines in bone strength, it's important to do those sort of impact type of exercises. So jumping type of things or team sports which require that running, changing direction, stuff like that. But the one thing that has the lowest participation rate in middle-aged and older adults is resistance training. And I'm not speaking just females, I'm speaking sort of generally speaking as people get older. People are just less likely to engage in resistance training. Here in Australia, I think it's middle-aged and older adults are less than 20% of the population might engage in some form of strengthening type exercises. Whereas up to 70% will engage in sort of aerobic base, whether it's walking or doing those other
Yeah.
types of exercises. So resistance training is really important. And it is specifically, as I was saying, in terms of the bone health as well, it's really important in aging females. And sometimes it'd be hard to get started in progressive sort of resistance training. But we did publish a paper back in 2022. We did a review on optimal type of training we might be able to do. And a combination of resistance training, so lifting weights, but also doing some impact loading for bone health seems to be ideal. And the load, the resistance that people are lifting doesn't have to be great. So especially if they're novice or just starting, that the resistance can be quite low to start.
Hmm.
It's ideal that we progress towards higher loads, sort of around 75 to 80% 1RM. But our paper showed that sort of 3 sessions a week, 2 being resistance, 1 being impact loading, starting light with loads but progressively increasing them. 1 to 2 sets per exercise, doing 6 to 12 reps. Sort of that seems to be a bit of a sweet spot. So I'd strongly encourage females to participate in sort of more physical exercise, but also really make an effort to engage in progressive resistance-based exercise. So that's from a general neuromuscular point of view. Then, in terms of the effect of that different exercise on the hormonal sort of shifts and the fluctuations, sort of a little bit less known, and whether or not, the exercise itself is going to be beneficial, whether or not it has an effect on the hormones. So it shouldn't be the sort of deciding factor, but there's been evidence to show that doing sort of aerobic sort of impact loading exercise can result in some acute increases in estradiol concentrations, which is not a bad thing. Resistance training alone doesn't seem to, or may not have a direct effect on sort of acute changes or changes with training on our hormone levels. But as I said, the benefits of that go beyond just the effect on our hormones. But sort of identifying that, again, more research needs to be done in understanding the optimal type of exercise program, which not only has the wider benefits of improving aerobic capacity and strength and bone strength, but also there's sort of whether or not that can affect the hormones and whether or not that hormone effect has any additional effect on the adaptation that we might see with training alone, let's say. The other thing you mentioned there, I think, was hormone replacement therapy. So that's certainly one thing that I'm very interested and keen to sort of look at as some of the next steps. So there's been some reviews to show HRT has the potential for increasing muscle strength without influencing muscle mass. So that leads us to then the question, well, if the mass isn't explaining the improvement in strength, then what's happening? So there is potential there that HRT might improve the skeletal muscle quality. So whether that's limiting the infiltration of fat within the muscle, or whether that's improving the contractility sort of component of the muscle, which I was speaking about. And then also looking at then, well, if it's not, doesn't seem to be the quality, or if it's the quality is not changing, then that refers to then, well, there has to be some sort of neural thing going on. So I'll be really keen in the future. I'm really keen to try and do some work in HRT. We're doing a review at the moment, but that will hopefully form the basis of some form of interventional trial in the future. Yeah, HRT seems to be something which is sort of promising from a neuromuscular perspective as well.
Yeah.
So it could be something that's worth considering. HRT can have some other benefits beyond neuromuscular function in terms of cardiovascular health, obviously bone health as well. And it has been related in some studies have shown that it can sort of reduce mortality risk as well. There are this traditional sort of stigmas around HRT and potential for increasing cancer risk and things like that. But there's a lot of those original studies which seem to suggest that even reanalysis of the same data and accounting for different things which seem important, such as the timing of the HRT post-menopause, the combinations of the dose that they're having, the body composition of the person, whether they've had cancer in the past or not. So all these things, once they're accounted for, seem to mitigate some of that sort of cancer risk. So, but HRT could be something that people could speak to their sort of GP about exploring further. But there seems to be, from a neuromuscular perspective, some benefit there, but we don't really know how HRT is affecting the neuromuscular components.
Cool. And so you mentioned the resistance training 2 times a week and then a third day of impact loading. For our listeners, what's an example of impact loading?
Well, so one of the biggest impact loading exercise is actually playing tennis, believe it or
Oh,
not.
yeah.
So that type of, so if you can sort of picture, it's sort of the rapid start stop, and that it exerts improves or stimulates that osteogenic effect of building bone.
Cool.
In a gym setting, it might be things, like jumping or bounding or these type of exercises. They tend to more relate to what we would say is an impact loading. So anything which is basically resisting gravity, and exerting some sort of like braking force, let's say,
Yeah.
throughout the bone. Yeah.
Cool. I would imagine too that probably helps with the fast twitch muscle fibers as well as the bone.
Yeah, potentially. The fast twitch fibers. So again, I think I touched on this maybe earlier, but the theory is with aging that we might get this preferential decrease or atrophy of the type 2 fibers. That is something that some people show. It's not something that everybody shows. And for instance, we actually, in this same cohort, and in this paper that was led by Annabelle Critchlow, who was the co-author on this, first co-author on this paper, but we didn't see the preferential atrophy of type 2. We did see sort of an increase in hybrid fibers. So there seems to be that there might be some sort of denervation going on, but the neuron is capable of sort of rebranching out and sort of combining fibers together. So type 1, type 2 fibers start to become a bit of a blend rather than being sort of more distinctly separate from each other.
Oh,
So, and that may be related to hormone levels too. So hormones might be, I think it was mainly estrogen may be related to an increase in this hybrid type of muscle fiber. But if we want to try and tap into, let's say, type 2 muscle fibers with training, one thing that does seem to be important seems to be the velocity of the movement rather than, let's say, the impact loading itself. Obviously, faster velocities can be achieved with lower resistance, but there is sort of an optimal resistance, if that makes sense.
yeah.
We're sort of, this is branching into what's known as the force velocity relationships of muscle and how that influences power and stuff like that. But in an attempt to try and stimulate, let's say, type 2 fibers, then the velocity of movement seems to be important for attempting to try and mitigate that. How effective it is sort of something else. Again, maybe yes, maybe no.
Yeah.
But it's a viable strategy for sure.
Very cool. Yeah. All of this has been so fascinating. So do you, from just a theorizing lens, I mean, we see this happening in women. Now we have this study in women. How does this compare to neuromuscular aging in men?
Yep. So we know that men are a little bit, let's say, more lucky when it comes to the age-related decline in that they still experience decrease over
Hmm.
life. Seems to be a little bit more linear
Mm.
than sort of the non-linear decline we see in females. The onset of the decline doesn't seem to happen as early as what it does in females. So it's
Okay.
generally sort of later towards the 50s rather than sort of the 40s. And the magnitude of the decline doesn't seem as great. So they don't seem to lose a greater percentage, as much a percentage of strength and mass as
Hmm.
females do. The reasons potentially for that, there's more known in males,
Hmm.
and in terms of relationships with androgens,
Hmm.
so mainly sort of testosterone, that people sort of know about. But the amount of testosterone seems to have quite a strong correlation with strength and mass in males. And
Hmm.
because that the alterations and the fluctuations in testosterone across a male's lifespan, again, are a lot less dramatic than the fluctuations that we see in estrogen and progesterone, the main ones in females. So we definitely see this degeneration occur in males, but it doesn't happen until later in life. It seems more is known about the relationship with the testosterone changes over the lifespan. So it doesn't happen as early, and the magnitude doesn't seem to be as great.
Hmm. Yeah, fascinating. So, where would you like to see research go now that you have this information?
Yeah, so we've got a couple of things that we're doing ourselves. So as I mentioned, right now we are looking at power
Hmm.
production rather than sort of strength, let's say, and that relationship between the velocity of the muscle contracting and the force and the power that it can generate.
Hmm.
So that's one thing that we're sort of looking at, and trying to look at how the hormones might be influencing power, which is a little bit more, let's say, functional. It's a little bit more relatable to what we do
Hmm.
in everyday life. We're also about to do a study looking at getting a closer insight at specifically the signals come from the motor neurons in the spinal
Hmm.
cord. So measuring the actual motor unit, which is the
Wow.
nerve cell and the muscle, yeah, the nerve cell in the spinal cord and all the muscle fibers that it controls, but trying to really get more information about that signal using
Hmm.
that high density electromyography that I mentioned at the start. So we're about to do that. We've got some funding to do that, which is great. And we aim to look at that during rapid contractions, but we also are looking at submaximal contractions. So again, everyday life requires the
Hmm.
muscle to generate sort of submaximal levels of force, not always trying to generate its maximal level of force. And so we want to try and look at how the signal being sent to the muscle controls what's known as force steadiness. That's important for balance control. So obviously in
Mm.
females as well, females are more likely to experience fall-related fractures and things like
Yeah.
that. So that gives us another sort of look at the functional level of the neuromuscular system. But that's a study that we got funding for, led by Professor Lamont. I think, yeah, started this year. So we've sort of been preparing for that one. So that data collection for that should start sort of early next year. Um, the other thing we want to look at, from a molecular point of view, would really love to get, especially now from this work that we've shown that this seems to be some things going on within the muscle itself. So looking at the
Hmm.
muscle at a molecular level. So we can look at things, or potential biomarkers for the actual integrity of that neuromuscular junction, and
Cool.
also the integrity of the calcium pumps, which are responsible inside the
Yeah.
muscle for sort of regulating the contractility.
Wow.
As I mentioned, the HRT stuff.
Yeah.
So we're doing a review and sort of embarking on that. So they're all things we're kind of working on at the moment and that are going on in the background. Future things, also interested in looking at sort of the systemic hormones versus the intramuscular hormones. So
Mhm.
skeletal muscle itself can produce some estradiol. And there has been some sort of studies to suggest that those hormones produced by tissues other than the, say, ovaries may also be stronger related to strength and function within the muscle. So they requires biopsy data, and it's a little bit more invasive and
Hmm.
more expensive. But yeah, looking at intramuscular hormones is something that we'd sort of like to look at in the
That's
future as
fascinating.
well.
Really cool. That sounds like a ton of amazing research. And again, like super stoked you're doing research on women too
Mm.
and looking at all this. I think that's, yeah, just, yeah, yeah, I think it's fascinating. We need more research to sort through. One last question that we
Yeah.
have for you from like a summary takeaway for our listeners. If there's three bullets or summary notes that kind of takeaways that you would want to share with our listeners or coaches or any clinicians tuning in for their
Mhm.
patients or athletes that are maybe getting older or going through perimenopause, any quick nuggets or suggested takeaways for them?
Yeah, I guess the main thing I think from the paper is to really have a greater awareness that menopause can be. It's a really important transition period throughout a
Mhm.
female's life, and it has distinct biological sort of consequence. From our point of view, it's really important to understand that when during that transition period, there are these hormonal shifts which have these effects on someone's physical function. And we're showing the physical function in terms of strength and mass and things like that in this paper, but also in terms of the other symptoms that females go through, like irritability and, hot flushes and all that type of
Mhm.
stuff can really impact a female's life. So I think it's important for clinicians and coaches and females and also males to really have a strong awareness and understanding that it's an important transition period
Mm.
of the person's life. So, things that we can do to try and I guess mitigate that and understand it, or strategies we might be able to explore to try and help through that transition are important. So, physical exercise and resistance training are obviously important, and
Mhm.
adhering to that type of resistance exercise is important because the hormonal shifts are going to happen. So we need
Yeah.
to try and do something to try and let's say somewhat combat it. So
Mhm.
progressive resistance training seems to be an important thing. Other potential strategies that might be worth exploring, such as HRT, as I mentioned. But the important thing there, I think, is just the awareness of what's happening during menopause.
Mhm.
Um, and then also, yeah, trying to engage or explore strategies which might help people better deal with that
Yeah.
transition. Um, but yeah, and then the other thing I guess is there's the paper sort of sets the scene for I think there's a lot of avenues to look at things in more detail. So from a
Mhm.
sort of motor unit physiology perspective and also from an interventional sort of perspective.
Cool. Yes, I love that. Okay, I'm gonna jump back to your two truths and a lie. We're gonna hear some hopefully some fun stories, I think.
Okay.
You said you were bitten by an eastern brown snake, which is the second most poisonous snake in the world, that you had a kookaburra swoop down and grab, I think you said food out of your mouth or food as you're about to take a bite,
Yeah.
and that you've seen a great white shark breach out of the water while you were in the water.
Mm.
I thought the snake bite was a lie. Which one was it?
Yeah, the snake bite was a lie.
Oh, okay.
So that hasn't
Yeah.
happened. I have been very close. So I like stepped sort of about this far away from one once
Oh,
before.
wow.
But they're not usually aggressive. I think that's
Oh,
one
good.
thing here in Australia. We've got a lot of poisonous snakes, but they're
Yeah,
generally not aggressive, and you generally
that's
don't
good.
really see them very often.
That's
I
good.
was just walking through the long grass, and it was warm, and that's not the right thing to be doing.
Yeah.
I was camping at the time, but yeah, haven't been bitten.
Wow. Yikes. Well, I'm glad
Luckily,
you weren't bitten.
yeah, yeah.
And a kookaburra did steal food out of your mouth, or like
It
as a
did. I
takeaway.
was eating a hamburger. I was camping and yeah, I had in my mouth and it came down and took it straight out of my mouth.
That's
So it
funny.
was yeah,
Yeah.
it gave me quite a shock.
Yeah. And then were you out surfing or when you saw the good wake?
Yeah, yeah, this one wasn't that long ago. This was probably it was about February this year.
Oh, wow. Yeah.
But yeah, I was surfing and I was just watching I'm not a very good surfer, by the way. I try my hardest, but I was watching the sort of the sets come in, and then yeah, it was about sort of 100 meters or so from me. I just thought just shoot straight
Oh,
up out of
yikes.
the water, and
Yeah.
yeah, it was hard to process because it seemed a bit surreal, but then
Yeah.
yeah, I processed it and then got out of the water.
I was gonna say, yeah, do you see it that far away and you're like, maybe I should go to the shore?
Yeah,
Yeah.
yeah, yeah. But
That's
that was quite an experience as well.
yeah. Gosh. Yeah, all the deadly things in and around Australia.
Mm.
Do you know what, just maybe you don't, but do you know what deadly animal in Australia like has the most deaths, like causes the most deaths of all
Oh,
deadly?
I don't actually. I
Okay.
suspect, yeah, because I think with snake bites, I think they have antivenoms for them.
Mm,
But the problem is here that most snake bites will happen in outback Australia,
right.
so where there's not a lot of care that can come
Yeah.
quickly. Um, but yeah, I mean, we've got lots of great whites, but shark attacks they happen, but they're quite sort of rare, let's say.
Yeah.
Um, but yeah, I actually couldn't tell you which animal is responsible for the most deaths here in Australia. I'm going to look it up though
Yeah, I'm
after
gonna
I
have to do
get
some
off this.
Googling after. Okay, well, where can our listeners find you, follow your research, any upcoming conferences you're going to be speaking at, anything like that, where they could see your stuff?
Yeah, I don't have any conferences planned just yet to be
Mhm.
unfortunately. But yeah, I'm happy to I'm happy to share my work email. So if anyone wants to contact
Okay.
me, they can directly. It's probably the best way to get to me directly. Also on LinkedIn, people can link up with me there. I'll also share my sort of general researcher profile that we've got from
Hmm.
university, and
Yeah.
I'm on X or Twitter as well. I'm not prolific tweeter. I don't know
Yeah.
if that's still the term now that it's called X, but whenever I do publish or something comes out, I generally share some sort of snapshots on
Awesome.
X as well. But yeah, they're probably the main areas where people can contact me.
Perfect. Well, we will link all of those in the show notes for our listeners so you guys can follow Stephen O'Brien's research and what he's up to and posting about. And I'm sure we're going to have you back when these other papers come out. So,
Yeah, I'd
um,
love to.
yeah, listeners, stay tuned. This has been super informative and fantastic, and I really appreciate your time, Stephen. Thank you so much for joining us.
It's my pleasure. Thanks, Carla.